आई रियलाइज कि वो सेंड से है, अभी आपका टाइम वेस्ट होगा। फिर मेरे को 2 चिट मिल गया था तब तक कि सर द गेस्ट आर ऑलरेडी वोटिंग इन द वोटिंग रूम। तो मैं इसलिए भागना था इमीडिएटली आपका काम करके, तो वही था।
नहीं सर, वो कई बार होता नहीं है। हमने आपने कराई थी ना, यहाँ पे भी तो कराई थी हमने उस टाइम हैंगआउट पे। STP
participants, like what is the level of participants?
From all over India.
Mixed.
No, sir. Faculty members.
The maximum faculty member. Okay.
Any asnar?
Time. Yeah, Manisha, can we start?
Yes, sir. Yes, sir.
So sir, already...
good. Okay, sir. So good afternoon to all the respected dignitaries and participants. I, Dr. Manisha Bhatt, on the behalf of EC Department, Govind Ballabh Pant Institute of Engineering and Technology, would like to welcome you all for the second day afternoon session of this Atal Academy sponsored 1-week online FDP program on antenna design, fabrication and measurement. It's a great pleasure and honor for me to introduce speaker for today's session, Professor Shyam Sundar Patnaik. Presently, he is Director of National NITTR. Before joining to the post of Director, Professor Patnaik served as Vice Chancellor of Biju Patnaik University of Technology, Odisha. He has also completed his postdoc research from University of Utah, USA, and PhD engineering from Sambalpur University, Odisha. Under the able supervision and guidance of Professor S.S. Patnaik, 23 students have completed their PhD, and one more is pursuing his PhD work. He has 52 ME theses to his credit and has published about 280 papers in journals and conferences of repute. He has 2 international books and 4 international book chapters to his credit. A recipient of Boycast Fellowship from DST, Professor Patnaik also is awarded with SERC Visiting Fellowship, INSA Visiting Fellowship, UGC Visiting Fellowship.
Madam, this biodata was read in inauguration time.
Okay, sir.
So we can
Sir, if you want to,
straight way we can go to the academics. So if you allow me, then I'll
sir.
start the academics.
Yes, sir. Yes, sir. Yes, sir. You can.
So I'll share the PowerPoint now. So is it visible, madam? The PPT of mine?
Yes, sir.
PPT is visible. PPT is visible.
Okay. Screen. Yes, sir. Okay.
Is it visible now?
Your screen is shared, right?
Screen. Yes, sir.
So the PPT is visible.
So PPT is not only screen, the desktop screen is visible.
Okay. Wait a minute. Then I'll... It now?
Sir, only screen is visible.
But not in, okay. It's a straightforward thing. It is showing sharing. I don't know it is why it is not so, because On my screen only it is there.
Sir, your screen is shared. What you can do, sir, you open PPTs at your system, then it can be shared.
That is what I am telling. I have already opened. I have already opened.
Uh,
If the screen is coming, then this screen should come. This is in the desktop.
So just minimize this like browser button. I think then yes,
Now,
PPTs will be visible.
now you see the screen. Do you see the screen? So Gautam, do you see the screen?
yes, sir. सर अभी तो आपकी शेयर स्क्रीन ही शेयर हो रही है खाली.
नहीं, मैं पूछ रहा हूँ स्क्रीन दिख रहा है क्या? स्क्रीन दिख रहा है मेरा? डेस्कटॉप स्क्रीन दिख रहा है?
यस सर, यस सर.
ये मेरा माउस जो मूवमेंट आप देख रहे हैं?
या आप ही आपका सर वो ओपन है, आपका ब्राउजर ओपन दिख रहा है यहाँ से सर.
ब्राउजर नहीं कर रहा है. एक मिनट रुकिए.
अब आप आ रहे हैं सर, मतलब आप नजर आ रहे हैं. वीडियो इज ऑन. इसमें ऊपर शेयर्ड में आप यहाँ से व्हाट यू कैन डू ब्राउज बाय माय कंप्यूटर से करके देख लीजिए. यस सर, नाउ
Now it is.
Yeah, now it is visible. Yes.
सर आप इसको स्क्रीन मोड कर लीजिए सर. ठीक
मैं
है.
कर देता हूँ. मैं कर. Is it okay?
या सर हो रहा है.
Can you see it?
सर अभी स्लाइड शो नहीं हुआ है, वैसे आपका पीपीटी नजर आ रहा है.
वो पीपीटी के ऊपर ये स्लाइड शो क्या है? I don't know.
मे बी सर दैट इज ड्यू टू द इंटरनेट.
एक बार देखता हूँ. अभी देखिए. Is it possible?
इज चल रहा है सर, स्क्रीन मोड में नहीं आ रहा है. स्लाइड मोड एक्टिवेट नहीं हुआ है अभी. इतना तो टाइम नहीं लेता है. हाँ सर, अब शायद हो जाए. अगेन टर्न टू द सेम.
कोई बात नहीं. सेकंड्स में विजिबल. It is not on
yes sir,
slide mode.
visible.
Okay. So one participant, good afternoon. किसी का म्यूट करना पड़ेगा. किसको आ रहा है?
एक आपको म्यूट कर लीजिए सर, आप नहीं आएगा.
Sound is getting low.
Yes sir, please continue.
So basically, the talk which I am going to interact with you is what the biomedical arena. I will not discuss detailly hard communication, but I will discuss something on how the design, fabrication, and measurements have to be ensured while going for the biomedical arena. गौतम जी, इको ही आ रहा है.
इको आ रहा है सर, इको आ रहा है. एक्चुअली सर आपने दो सिस्टम से साइन इन कर रखा है क्या सर?
नहीं तो एक ही में क्या लाइक गो कैन कम इन अगेन. अरे एक बार लॉग आउट करने दीजिए, फिर मैं आ रहा हूँ.
ठीक है सर, प्लीज. Now it's okay. सर आपको सर मैंने इसका आरडी पासवर्ड भी भेजा सर, उससे भी आप साइन इन कर सकते हैं।
वो तो मुझे पीपीटी दिखता है कि नहीं अभी?
अभी सर आपकी स्क्रीन आ रही है, इसमें आपका ब्राउजर ओपन है।
एक्चुअली ये डबल ओपन हो जा रहा है मेरा ब्राउजर।
जी सर, इसको सर मिनिमाइज कर लीजिए सर, हो सकता है उससे प्रॉब्लम सॉर्ट आउट हो जाए।
नहीं, मैं करता हूँ इसको एक बार। मिनिमाइज करके ही कर रहा हूँ मैं। अभी पीपीटी दिख रहा है क्या?
नो सर।
और फिर
अभी नहीं सर।
टीम में कुछ मेरे लिए ये इस कंप्यूटर में शायद वो प्रॉपर apps डाउनलोड नहीं हुआ है। आई थिंक अभी आएगा, तो लेट मी सी इट।
हाँ, अब पीपीटी आपका ऑन हो रहा है सर।
अब पीपीटी स्लाइड मोड गया है?
नहीं, स्लाइड मोड नहीं है सर, बट इट्स ऑन।
ऑन ना? ओके। Okay, fine. We have to manage this way. I don't know. Maybe proper browser मेरा support नहीं कर रहा है टीम को.
Maybe sir. Please you continue.
I'll check that later on. But anyhow, so coming to the point that I am going to discuss something on biomedical antenna design, fabrications, and as well as measurements of those antennas. They are slightly, they have a major difference in terms of its measurement setup, its fabrication, and also in terms of design. So to give an idea, when we talk about the biomedical antennas, biomedical, when we are talking, we see how much impact it is really giving on different type of organs, whether it is your ear, whether it is your head or finger, skin, whatever organ you are talking about or whatever body parts you are talking about, how much impact the radiation is giving on that is to be seen. And that is done through a process and a terminology called SAR, specific absorption rate. So that is the basically the quantitative notation of how much radiation will be impacting your body parts. So in these type of measurements, what is done, the dummy phantoms are used because you cannot directly expose a person in front of the radiations initially, unless you come out with a quantitative parameter, how much to be exposed. So when you are doing this type of the prototype study, you cannot directly bring a human volunteer in front of the measurements and start working on the volunteers. So in that type of situation, what is done, you have to work with the phantom. So the phantoms are to be having the electrical properties which are having the equivalent electrical properties as for the organs or the body parts which you want to get it exposed to the RF radiation. So like if you see here, this is an old slide of my doing the measurements for the Motorola antenna. If you see here, there is a small tip where the antenna is visible. I don't know whether you'll be in a position to see or not. Top of this head, there is an antenna. And so this particular phantom, if you see here, this call is made up of that material which is almost all having the equivalent electrical
The slide
properties.
is not moving.
Sir,
Slide
sorry
is
to
not moving,
disturb
sir.
you.
Only the
Slide,
first slide is open.
first slide is so only.
Only the first slide is there, sir. It's not moving. What is slide you are talking, sir? Good afternoon.
Maybe some issue on the internet, what I'm thinking.
This kind of.
So all the participants, be patient. Sir will be joining soon.
Now I think it must be okay.
Yes, sir. Now
So,
it's okay.
you must be seeing this slide now, sharing also. Is
Yes,
that
yes.
okay? Anyhow, so this slide is visible.
Yes, sir. Yes, sir.
Okay. So the thing which I was explaining is that when you are trying to do some activities with the biomedical antennas research, then you have to deal with the phantom. And that is what exactly I was explaining, that if you see this phantom, here this phantom skull material is having the same electrical properties which our own original skull is having. So you have to choose that type of material which has a equivalent electrical properties which is supposed to be interacted by the RF signal. So in this case, this skull is there. Inside that, this pinkish material or the pink color material which we see, this is that exactly having the same electrical properties which our soft tissues are having. Near to the ear, we have soft tissues around. These soft tissues will have the same electrical properties as the material which is pushed inside the skull, which is having a pink color here. Therefore, when you are dealing with the biomedical antennas and biomedical radiation exposure study, you have to first get acquainted with those materials which can be picked up in the laboratories, which can be used for the respective organs representation, and which should have the similar electrical and magnetic properties as is required in the body organs. Mainly the electrical properties we looked at. So if you see here, I was showing you the antenna that time. If you see, this is a Motorola antenna, which is fixed here near to the head because we wanted to have a study of how much exposure there in the head. So that's the way this exposure study used to be carried out, the place where I was there. So now, if you see the electrical properties, as you know, the materials which will be picking up, this will vary with their electrical properties will vary with the frequency. So that means again one more important aspect which you have to keep in your mind, that what is that frequency on which you are working, in which on you are working. Now for that frequency, what are the electrical properties? Mainly the dielectric constants and the conductivity, all these parameters needs to be measured, or if the tabular form is already there supplied by the company, that has to be considered. So if you see here, the materials which we used was based on the measurement carried out by Professor Camellia of King's College, UK. She was part of our group. So whatever measurements she used to carry on these material properties, we used to use those materials to replace bone with the equivalent materials, replace muscles, fat, brain, skin. If you see, that is the way, and their electrical properties in terms of the dielectric constants are measured by her, and it was supplied to us. We used to have these materials in front of in our simulations and as well as experimental. Sigma, the conductivity also used to be in this way. And as you see, as the frequency changes, their properties are also getting changed. So that is a very important aspect which you have to keep in your mind, that if you are going for a material in place of a original biological replacement, then obviously the frequency relations to be kept in mind. Then what is that the exposure study needs to be quantified? The exposure study needs to be quantified in terms of the specific absorption rate. You might be knowing that when you buy a mobile phone, in their manual, it is mandatory to mention what is the SAR value. So if you pick up any of the phone, you will find the SAR value is also mentioned. So the SAR, which is a specific absorption rate, this SAR is dependent on the conductivity and the peak electric field, which is due to the radiation from your system, and the volume, that is the density. So that is the things which you have to consider. If it is too much voluminous, obviously the radiation will get distributed and the impact will be less. If it is a small thing, the impact will be more for the same field. So that's the way the specific absorptions are considered. Suppose you are going for a whole body exposure, somebody is going for with the same field, only exposure to the, let's say, heart or exposure to the face, then that impact on face will be much more when it is going for a whole body exposure, because the same field, same amount of field, you are giving exposure to the whole body, whereas the other person is giving exposure on to the face. So that's the way you have to see to it. And this is one of the things which I would like to see. This is an experimental study which we are doing. So when we took this data and started plotting it, both experimental and the FDTD simulations were matching very well for 835 megahertz, a monopole antenna of Motorola. And this is the way the distribution used to take place. The pink color, if you see, the high scale is in these pink sides. So wherever you see pink color, these are the high deposit area. That means these are the soft tissue region which used to have maximum deposition from this radiation. So now these radiations again varies from frequency to frequency, also from age group. That's why when you are going for a biological study, you have to keep a target group in your mind. Your result for teenage will not be applicable for senior citizen. So that needs to be kept in your mind, because lot of body changes, physiological changes takes place, and that affects your electrical properties, and the interaction of RF exposure will be also different for them. So therefore, when you are going for this type of study, remember here I am showing you the SAR deposition from a mobile phone at 1900 megahertz wireless devices, 10 years adult, 10 years, and the adults and the 5 years kid. If you see, there is lot of variation. The deposition in the adult head is less. Though the head size is big, it can intercept maximum signal, but since the soft tissue or the fluid component is less compared to a child, so child absorbs maximum of the signal because they are more lossy in nature compared to the adult head. So that's the way these SAR depositions are shown here. And also, the orientation of the body parts affects the radiation. The orientation of the body parts will affect the exposure parameters and the quantitative results which you are getting. So if you see this study also, it did like tilting, rotating, even like comfortable position, all those things, studies were done. So that's the way. I need to tell you that when you are going for measurements of the biological type of materials or biological type of study, the antenna needs to be really set in a proper format, frequency, electrical property, their orientation, their fixation needs to be very meticulous. And since biological applications are dealing with small antennas, therefore any small perturbation, थोड़ा सा भी soldering का अगर वो ज्यादा सोल्डरिंग हो जाता है, वो अफेक्ट करता है आपका पैरामीटर्स एंड मेजरमेंट्स को. So that's the way you have to be very careful. Then biological study में one of the study is a uniform based study. Like the materials or the devices will be fixed to your uniform, not to the body, and how it really interact with your body and gives back a result. So we did conducted some study in this direction. So if you see here, this is a security guard whose the front pocket is having antennas. And this is a cloth antenna, wearable antennas designed in this institute. This is a again wearable antenna which was fixed in the school bag. The kids which are going for the schools, so they were also fixed. So intentionally I kept not the finer antenna which was designed here. Intentionally I kept the rough antenna to show you that how difficult when you are dealing with the wearable antenna, because wearable antenna is a requirement for biological study. If you are not directly implanting or pasting your antenna at the human organs or human body parts on the screen, then obviously the biological information can be obtained through your dresses which you are wearing or the bags which you are holding. So when you are going for this, here if you see the copper patch, these are the copper patch. These copper patch are basically your, like this is, let's imagine like a microstrip antenna. So the copper patch is basically the top patch. There is a bottom patch also which is copper, and now in between the dielectric is cloth. Now to prepare this cloth, you have to go with the sewing machine. So if your student is not good enough in swinging, you see how the swing has taken place in this case. But again, as this needles goes on this dot regions, it is not a continuous one, so there will be air gaps in between. So if these air gaps are not considered during your simulation, then your simulation experimental results will vary. And now, if you are going for a tap fixation, if your hand is not good, you will be fixing like this. Like yes, this small strip you will be cutting and you are going to fix that. And if it is not properly fixed, you will be fixing like this. So that affects the really the wearable antenna. Actually, it is an interdigital approach which we did in our antenna design, and this gave a very good result later stage. Similarly, we created an antenna for belt. So in this also, now a lot of other activities my student Joshi has already done. He has designed many such antenna. Now he is already a doctorate, so he is doing good work. Recently, he has been cited in IEEE Bombay chapter. So he is doing a lot of good work in this direction. So here also, if you see, there is a belt antenna. So what there is, like you, if you go for this car seat antenna, then the previous one which I showed is a cap antenna. So in this case, your main problem is that the dielectric which you are using is a very dielectric. कहीं foam लेंगे आप, कहीं gin material लेंगे, कहीं polyester लेंगे. So those dielectric material when you are taking and when you are fixing to a particular place, उसमें crease आ जाएगा, कभी bending हो जाएगा, because when you are wearing in the uniform, जरूरी नहीं कि आपका uniform always straight रहेगा. तो कहीं hand bend कर रहे तो crease हो जाता है. So in that situation, your antenna performance will be affected. So while designing the antenna, you cannot consider an ideal situation. So therefore, you have to do bending study. You have to go for the crippling study also. जैसे वो crease बन जाता है तो उसका क्या होगा? So these type of studies when you are doing, honestly, the CFT, the FICO type of those packages which you are using for antenna simulation will not give you the right result. उसमें वो component नहीं है. Those components you can build in by your own code. Like my group, they work in FDTD, finite difference time domain method. So finite difference time domain method में हम लोग इसको crimping, then bending, all these aspect we consider, and we put that. So partial simulation in the packaged softwares, then we bring that data incorporate this boundary condition, try to solve the FDTD code, and accordingly a hybrid type of approach we do so that we are nearer to the realistic measurement situation. So therefore, why I am insisting on this thing, it is not only the design which you are considering in the simulation platform. After designing, when you are going for the fabrication, there is a lot of precision requirement, starting from cutting to the different type of patches, drawing different type of patches. So ultimately the aim is that it is leading towards 3D printing. It is leading towards the automation approach of fixing this type of antenna. Hand mein aap karoge, if you are going for a handmade antenna design, then you will land up yourself in this type of situation. This is a handmade antenna design. So where fabrications, so design was by simulation obviously. When we went for the fabrication, you see how rough the fabrication came out. So to avoid this thing, ultimately you have to go for a printing technology method or the additive manufacturing method, then only it will work out in a right perspectives. So now once you do that, then as I was telling that bending studies are to be done. So now FDTD code can give you the simulation results. It can tell you that this much bending effect will be there, but in real life, in realistic situation, how do you study that? So you have to create that type of bending. Here if you see, these are the आपका water pipe होता है ना, water pipe plastic pipe को cut करके इसमें bending बनाया गया है, and the bending angle placement of the antenna on the different bending angle, these are studied. So then with this, again, when we are putting a additional material for study, then obviously it is a cascade of substrate or layering of substrate, then that simulation results again need to be run. So once you run that simulation results, accordingly the bending effects parameters experimentally when you measure, maybe you will find a good similarity between your bending as well as the simulation results which you have obtained through your own code. So my suggestion to the researcher here, that yes, these so-called packages are quite helpful to solve to a large extent of your requirement, but when it goes to a precision research and a research which is having a real life requirement and can be fit into a real life situation, then you have to again switch from that particular section of the simulations, get that data, carried forward to your code, and once you write your code in technology like FDTD, this, that, then it will give you a lot of freedom to really play with your design. I personally feel that if you can capture FDTD, that is a core simulation expertise that will give lot of exploration. You can really explore the type of ideas in many ways, and especially the biological effect things can be studied well. Now giving an idea about how actually the study, which is brain and heart communication, is linked. Let me just give you an idea. When you are going for the study of biological tissues and the antennas for biological application, maximum of our requirements which are difficult to really handle, one is your heart related diseases or the heart related issues, another is your brain related issues. I'm not talking about the inner organs like pancreas or kidney. Those are slightly much more difficult studies, because even the different type of layers you have to cross through to enter into this organ's behavior, and unless you have a right kind of doctor support, you cannot do that. But the straightway those studies which can be taken up is heart and brain related studies, because they are directly can be exposed to the radiations. Now if you see, primarily there are 4 waves in the brain which we tell them as beta, alpha, theta and delta, and basically these waves are to be seen how these waves, which are very low frequency, is getting impacted by the antenna radiations. So when you are trying to impact this particular waves, and these waves are having their own idealistic requirement, like if you want to have a concentration, then what do? You sit in meditation and try to get a concentration. That is nothing but generating the beta wave. When you are going for like you want to come out of your stress, you want to relax, so you do Anulam Vilayam. So that Anulam Vilayam gives you the relaxation. That is generation of the alpha wave. So similarly, in night time when you go for a certain type of kriya, which generally our yoga gurus they teach us that if you are having lot of dreams in your sleep, you are disturbed sleep you are getting, then they try to make you go for a dreamless sleep. This is nothing but that kriya which you do in night time through these yoga gurus. This is nothing but generating the delta wave only. So these are already the facts which are not new. These are already there, and honestly, these things are also linked to our state of mind. In our state of mind, if you see, we have, like I said, there is a phase we say always, I am frustrated with this. So when we are talking about frustration, this is the frustration which is a mental state of mind that time. So in that mental state of mind, how your heart is behaving. So that is very interesting study which was carried out, and I have just borrowed from them to show you that when a person is in the frustration stage, his mental condition is in frustration stage, his heart rate is going like a noisy wave. You see the heart rate is going like a noisy wave, and it is changing from 60 to 90 plus like that. It is a frustrated wave. But when you are appreciating a person, lot of good word is told to a person, that appreciation is a soothing activities. It is soothing activities. So this soothing activities obviously will not have a noisy approach. It will have a smooth approach. So our heart will have a smooth flow in that case, will not have any noisy type of situation. So if you see the mental condition of frustration appreciation is affecting the heart, then if you go for the heart rate variability, respirations and blood pressures, if you see the coherent study, this is a coherent study among these. So your respiration approach like Anulam Viloam controls the heart rate and that controls the blood pressure. इसलिए जो योगा गुरु रामदेव जी बोलते हैं कि अनुलोम विलोम करो, it is that respiration control is controlling your heart rate and ultimately it is going towards the blood pressure reading. So these coherent studies has been done by many researchers and things are available here now. Secondly, if you see the behavior, how the cardiac behaviors, already I have told you that cardiac behaviors, appreciation behavior already we discussed. In this appreciation behavior, when you are going for appreciations, your cardiac behaviors, how it is synchronized with a particular brain behavior activities. In brain activities, when we talk in terms of alpha, beta, gamma, delta type of wave. So now this, we have picked up a alpha wave. If a person without appreciation, then this will be his distribution. If a person, there is no appreciation in a normal state of mind, the baseline distribution will be like this. But now when you started telling a lot of good words to that person, then you'll see that this distribution gets changed. So the signals get excited inside that. The alpha wave gets more excited. So he is more relaxed. So lot of appreciations keeps a person come down from his stressful stage, and that is what is happening here. It is studied. Similarly, this distribution changes from male to female because there is a difference in the physiological structure. So in this, what happens? In a male body or male head, this alpha wave gets distributed towards the lower region also, like it comes from the brain's centering point towards the lower part of the head to the cheese also. Whereas in a female, maximum things get concentrated here. So therefore, if you see, when something is told, let's say your kid is coming from the school and telling some good news to you, the appreciations component from a mother is more than the father in terms of expression. It is not that the father is not happy, father is also happy, but while expressing, since the wave gets distributed, the alpha wave and the wave get distributed in brain, so therefore the expression, जब mother का 32 teeth निकलता है तो father का 16 के 20 teeth निकलता है. So there is a difference in this. but both are having the appreciation for the achievement. But interestingly, when we are searching how to go about this study, then we found that the electrical field of the heart is 60 times greater than the electrical field of your brain. So the point was where to enter through the brain or through the heart. Then we found a literature where it says that the electrical strength or field of the heart is 60 times better. So therefore, when you enter into a high field, a small perturbation can change or give you a visible jump. So therefore, we decided that we will work on the electric field. Similarly, when we started studying the magnetic field of the earth, then we found that the magnetic field of the heart is 500 times greater than the magnetic field of the brain. So then we took a decision, if at all we have to go for a biological study of a human organ, and if we want to study about the brain or the any type of brain activities, then let's enter through the heart, because the heart electric and magnetic fields are quite strong. A small radiation can bring a visible effect, and that visible effect can really be measured and can be captured and can be analyzed. Whereas your brain signals are very low amplitude signals in terms of electric and magnetic field. If you are doing some perturbation in that, it requires a bigger field to create a visible impact in that. So that's the reason we decided that we'll go from heart to brain. So while again going for this thing, any of the biological study when you are doing, very good thing for you is that skin is a very good interface for heart, brain, this type of organs. Any disturbance when you are creating on the screen, on the skin, disturbance get to the brain through the heart. So therefore, today's in the era of these printing antennas and 3D printing antennas especially, suppose you want to create a vibration in the human brain, so you can very well come with a 3D printing antenna put in the ear, and like the earphone you wear, and the earphone antenna can be given the regulated signals, and that regulated signal can create the required disturbance which is required in the brain. Create that type of alpha or delta, whatever wave you want to do it. So similarly, if you want to create a disturbance in the heart, maybe on the chest, a 3D antenna can be pasted, and that antenna can be regulated from the outside with the regulated radiations, and that type of disturbance can be created in the heart, which can control the brain also. So that depends how actually your research is taken care in this direction. So skin is a interface between heart to brain, and the antenna which you want to bring in terms of tattoos or printing on the skin, so those things you have to see that the material which you are using, that is biocompatible material, so that the interface between the skin and that materials which is a part of your antenna is well coupled. They are linked properly. So in this situation, this is people have tried many. If you see there is small transparent plastic type of color. This plastic type color is nothing but a biogel interface between the skin and this antenna structure. So similarly, if you see this is the biogel. This biogel material, top of his, the circuit and the antenna is fixed, and now if you paste it to the forehead, the forehead is completely coupled with the biogel, and this biogel is become a substrate. That substrate is supporting your antenna in upper and lower side. It is giving you the forehead a communications interface, and that becomes the printed antenna on the forehead of the person. So the communication is possible accordingly. So this is not that only head, any place this type of technology is possible, and that is what is the advantage when you are going for the biological study. So now going to show you some how the EM interactions really took place. These are some old studies, the old slide I am showing you, because recently we have moved towards the nano 3D printed antenna for this type of studies, and the studies is going in, like, again, I have not left that blended situation, but for you, I would like to show you that we used to have a sitting position, sleeping position type of situation. Like this ECG they are taking for me. When they are going for this ECG, this is my normal ECG distribution, and this is the HRV who is the because the software will support that, and you get the HRV in that way. When a mobile is used by me and I am in the transmission mode, I would like you to mark this. When I am in a normal mode, no mobile is being used by me. I have a normal person sitting in that place like my previous position. I'm not using any mobile right now. When I'm not using any mobile right now and my own ECG is being taken here, then I have a trace like this, which is, you'll see that my heart rate is between like 72 to 78, which is genuinely the right kind of thing. But when I'm using a mobile in the transmission mode, while you are using a mobile in a transmission mode, remember that the cord, this cord which you are using here, they should be actually taken care, because they become antenna to receive the signal from the mobile. So those things are to be checked properly. How much insulating approach is there? If it is not there, then you have to wrap the aluminum foil or the copper foil top of this wire to ensure that no external signal enters to this wire, and the wire should not act as an antenna to carry this signal to the system. So it should be a purely the effect of the internal situation. So therefore, this is the way when we are going for the mobile in the transmission mode, then you'll see that there is lot of variation. My heart rate one stage has gone beyond 94 when I was talking for a more considerable period. So that's the way. If you see, this is a visible results, and in receiving mode also there is a change. Receiving mode also, sometimes, as you know, in receiving mode you have a low signal, but the signals are more than the normal situation. So if you see here also, but if you are nearer to tower, the signal received is very high. So so that way, if you see, this is also showing that like 82, 85 type of HRV you will be getting. So that this needs to be marked. Similarly, like the people who are towards the more controlled situations, we have varieties of results here. One of the result I will show you, that is one of the students' result. You see, the peaks were inverted wave. Generally, in a ECG wave, it is upward, lower signal. The sync region is low, but it was inverted. Initially, it was a doubt that most probably maybe this is not the right kind of signal which is coming. Hello. Yeah. दे दिया हूँ मैडम, वोट दे के आ गया, मैं क्लास ले रहा हूँ अभी. So now this situation, if you see, this is a typical thing, but it is not a wrong ECG. Sometimes it shows that is what the doctor bettered that. So if you see these type of signals, when they are going to the transmission mode, the people who are habituated of using mobile phone for a quite long time, I was surprised to see that they were even touching very high bits rate. Like if you see 120, 130 is the average in their receiving as well as transmitting mode, and it was very surprising. Then we went for PhD, this power spectral density calculation. In power spectral density, easily you can see that in a transmission mode, you see the peak is here. In receiving mode, the peak is changing. It is has a displacement. Similarly, in a people who are continuously using the phone, their peaks are very high, large, and when you are going for their HRV situations, then you'll see that lot of variations are happening. There is a noisy effect. So it is not that the radiation doesn't affect. The radiation very well affect the heart rate, and that is, these are all the experimental results which are right in front of you. Similarly, some people, they keep their phone in the pocket. So this is also we took study of that. Even if you are not using and you keep your phone in the pocket, is it going to affect you or not? So those studies also we saw. Then we started classifying them, the observation in terms of 2G, 3G distribution. Now the 4G phone has come, or in that case, smartphone also is there. So these studies we have not taken up now, but these studies requires further, because the people who were assigned this job, they have already completed their PhD. Now, since new candidates have come, we are working on this 3D printing antennas and their impact. So now, if you see here, all components of the ECG like RR interval, HR, the peak values, QRS, all those things were considered for the, so segmentation wise for various channel we started. Then even the power level, the bits per minute, frequency, all these components for each individual we took. So in terms of your ECG signal, the ECG signal was segmented, those parameters were tabulated well, only 2 slides I've shown, but it is a voluminous work. Then the same subjects were now connected to EEG, and this time, remember that the ECG and EEG which we used to take is simultaneously we used to take. Once the individual EEG, ECG are classified, once those data are isolated, then the measurement stage when we are going to study the impact of this radiation, then we used to take simultaneously ECG and EEG. So this is that situation where a subject is asked to keep the eye closed so that blinking noise will not come, and he is first allowed to sit in a normal positions. ECG and EEG signals are recorded. Then this subject, so this ECG stress has taken, so then the subject is allowed to use the phone without opening the eye, because that eye closed situation has to be maintained, but its mobile phone reacts, he was allowed to use the mobile phone. In one case is transmitting, emitting, another case is receiving. Then these signals, if you see, the same, we have collected almost 75 subjects were with us, so, and we use those subjects. Now this acquired signal needs to be processed, and that is what is the main job, first to select the right kind of filter. So if you cannot select a right kind of filter, your filter will pass the noise and your genuine signal will get suppressed. So this filter selection is a challenging job, and lot of trial and errors, comparison with the results and vetting with the doctors is required at this stage. So once these signals are extracted after filtration, then you have to now segment this signal. So like the P wave for 2G, RX means your reception mode, QRS in RX, T wave in 2G RX. Similarly, if you see delta wave in 2G, theta wave in 2G in transmission mode, and the location, node location, like what is the sensor location. So like 19 node signals, this ECG, EEG we were using, so they have different nodes to be discussed in that. So once you get these signals, the alpha, beta, gamma, all the 4 signals were extracted, because it is HRV also is this your ECG signal is also extracted, as well as your EEG signals are also extracted. So then the coherence analysis we started using. Then we started doing the coherence analysis between this extracted ECG signal and extracted EEG signal. The coherence analysis which was carried out, if you see these slides which I am showing, are basically the coherence analysis of these signals. It is a different kind of exposure for me. Also, I was not expecting that something like that will happen. So if you see here, signal by signal coherence we started. How the QRS wave of art is impacting a variation in the QRS section is impacting, a variation in the P section of the ECG is impacting, a T wave is impacting in the various signal of the brain, the delta, theta, alpha, beta, gamma, that signals which are there in the brain, how they are getting impacted by a particular change of a ECG signal, because ECG signal is a continuous trace. So in that particular small section, when there is a variation coming in P wave, how exactly pinpoint it is. So that is the purpose of coherence. So that one-to-one correspondence analysis we can do, but it is really difficult. We did that. So now if you see a lot of this, and again this when you are going for the EEG signal, there will be a lot of node issues will come, that which node you are considering, which part of the delta wave you are considering. If you see that, that is what is changing here, PF1 7. So like that variations will come. Lot of this web, basically, if you see here, the ECG segmentation and this thing. So the coherence and correlation study, when we did, we were not knowing that we will be getting a sensible result. But it gave us a hope that these signals are having an interlink between them. And that is the reason that we went for a strong discussion on which parameters to be considered. Then we decided that you cannot leave nonlinear parameters. Only linear parameter will not give you a right kind of information, and we cannot reach to the location which we are trying. So we also consider the nonlinear parameters. If you see here, in terms of the linear parameter which is conventionally done for ECG analysis, your mean HR, then standard deviation, root mean square. So like that, these are linear parameters which are in time domain, frequency domain, like that we used it. But if you see linear parameter in frequency domain, your frequency will come, VLHF band, LF band, all those things will come. So we took the linear parameters in time domain, linear parameters in frequency domain. Both the domain studies were done. After that, we took the nonlinear parameter. In nonlinear parameter, the entropy, if you see here, the previous one is a entropy analysis. Then we took correlation dimensions. Then we discussed the recurrence rate. Then in the entropy also, like which entropy to be considered. That is also again a type of analysis and studied we did, that which entropy will give a, if there is small change is taking place, which entropy will give a right kind of visible variation to us so that we can measure it. In addition to this, also we did some statistical result analysis, like t-test, t-pair test, like that we did. So both the Vehgal type of studies, the nonlinear analysis studies, linear studies, all those things are now distributed in terms of our locations, how they are really getting distributed and what variation is happening due to this type of exposure, which the heart is also changing as well as the brain is also changing. So in the brain, we decided that in the two way, like low value and high value situation, the red colors, the pink colors are basically high value situation. And if you see, it is delta power, it is theta power, alpha power. Basically, the 5 brain waves are considered here. And you'll see that the variations having a visible impact in alpha power. The alpha, this is the alpha wave, which I'm showing the third figure. So the alpha wave used to have lot of locations with the pink color, and when you were seeing in the screen, it was giving us a right kind of visible, measurable variations to be noted. After alpha, it was delta. If you see your delta also, the first figure is delta. It is also having a considerable. But the variation in other 3 waves like delta, beta, and gamma, they were very less. We could not really measure these 3 components, even though there was a possibility of beta power, but sometimes it was getting more with the noise. So I asked them not to go for these 3 waves. We only concentrated in these 2 waves, alpha and delta wave, and we concentrated how this alpha and delta wave can be actually controlled by this type of things. If you see, one of the things I want to tell you, there is a nonlinear parameters. Maybe in this slide we have missed. One of the component like the Vehgal analysis has to be done. So we didn't leave anything in this particular study. So what I want to say here, in this type of biological antenna design and its ultimate application study, this type of activities requires not one parametric study. It has to be multi-parametric studies, and those studies, if not possible experimentally, must be carried out in the simulation situation. So while going for the design of the antenna, remember when your antenna is designed for a biomedical application, the antenna is in the proximity of a organ or it is touching the organ. So those loading factors those loading factors, the mutual coupling, how the self-inductance is changing, how the mutual inductance is changing, all those things are to be considered. And those consideration when you are doing, if your simulation software is not supporting, then you have to go for own coding using either moment method or FDTD or frequency domain FD. So there are many such approaches which you can do it. Also, if possible, do some mathematical analytics using the boundary value problems. But since like skin, when I'm talking about putting a tattoos on a skin, some people will have a very thick skin, some people will have a very thin skin. Then this on the skin there will be hairs. Some people will have a very dense hair situations. The porosity of the hairs will be more. So those components, when you are considering, this cannot be done in your normal packages which you use. Then how to incorporate that? Mathematically not possible. If you are trying, you cannot really analyze this thing. So ultimately, those type of environment you have to create using this type of approaches, and those codings requires first understanding the technology. So the numerical techniques which are available needs to be really understood before going for this type of analysis. Now, the interesting thing is that the 3D printing technology supported by the 4D. As you know, 4D is nothing but the material characteristics can be changed. The material characteristics can be varied to create a 4D situation. So in our antenna, this is very important. This is a really interesting thing. So when you are going for the 3D printing, if you are in a position to code in such a way that you are changing the material characteristics with the same materials, you are in a position to create another antennas for another frequency for another applications. And if both are embedded in the same 3D printing, that means your antenna is going to be an antenna of multiple applications, which is a present day requirement. And in fact, our own approach here, like bringing the nanomaterials in between and bringing this 4D type of material characteristic variation in the frequency, we are trying that can the single antenna be used, or the same packaging can be used for multiple frequency, multi type of application requirement biological field. So if it is possible, because in my opinion, if you see the healthcare system is looking forward to the RF group, and this particular group has not really contributed significantly into the healthcare system. It has a lot of scope. Only 4 or 5 days back, I have given one problem to one of my PhD scholar. This is on the COVID virus exposure and their behavior with the RF signal. Because the PGI doctor who is heading the virology department is a collaborator with me. So we have gone to that so far our RF people were confined to only imaging or creating this type of variation in the possible signal. This time I'm trying to enter into the virus world, whom you cannot see. Not much can be known about them, but we are trying. There is a paper in Nature which excited me that yes, there is a possibility that we can work on this. So I have defined a problem for that student. So this RF exposure field to the biological requirements is having a lot of scope, but it cannot be really done in a superficial way. It requires a meticulous test bench of setup. The test bench has to be vetted by the concerned specialist or doctor. You have to group with a doctor group. Then the doctor group needs to see your result. And my experience with the doctors association is, initially when you talk to them, they don't listen to you. They don't understand your language, the engineering language they don't understand. And they will talk something, their biological language or medical language, which you will also not understand. Then you have to decode. This is my personal experience I'm telling with my family friend who is heading the virology department. We did face that problem in 2010 when the swine flu was there. We wanted to develop an algorithm. Now that algorithm 2013 got published. The SIMBO, swine influenza model based optimization technique like PSO-BFO, is one of the original algorithm which this group has published. And it is a 23 pages publication in Applied Soft Computing. You can see that this algorithm, when we were developing, first 3 to 4 months, neither he was understanding me nor I was understanding him. Then I took a decision that I'll decode his language in engineering language. So whatever he is talking, let him talk, and I'll try to correlate with my own understanding how the electrical magnetic properties is, that I can correlate that. So when it happened that way, gradually we understand each other, and we started on the situation was that understanding each other, and ultimately we came out with a fantastic paper. And today he has again approached me, come with one of the students, let's do something on the COVID. And since I was reluctant because of my administrative load and the type of activities, I'm not in a position to concentrate more on academic at this stage. So, but now since I have my own student who have joined as faculty here, so that group is strong now. So we are working for this thing. So in this situation, what I suggest that those who are looking forward to biological type of applications antenna design, you cannot go for a shortcut path. It is my experience for last many years. Since 1996, I'm involved with this SAR measurement, this, that. So if you take my word into account, please don't use a shortcut method in biological antenna design, because it is not that simple like other antenna which you can design and you can test it. That is not possible. Second thing is that one of the suggestion to young researcher, you concentrate only size reduction design. कोई थोड़ा लेंथ कम कर देता है, कोई width कम कर देता है, कोई thickness कम कर देता है. So now it is time to think of volume reduction. So now it is time to think about the volume reduction. So when you are thinking about the volume reduction, your design cannot be too planar, two-dimensional. So you have to think about the three-dimensional design. Think about the 3D printing or the additive manufacturing approach. Then only you can come towards the volume reduction. So nobody is now interested in this small dimension reduction in terms of length and width. So come out of that mindset, go for the complete volume reduction approach, and in that, a multi-layer antenna, as you know, the stacking is possible. Different layers leads to a lot of improvement in the antenna theory. There are papers by us also. By slicing this substrate, you can improve the bandwidth, you can improve the gain. So this slicing, which we used to do very difficult way, like a substrate, instead of taking 2 mm substrate, 1 mm or 0.5 mm, 0.5 mm, so that inbuilt air gaps is created, and that gives you a better bandwidth. So those type of situations, this slicing can be very well realized in the 3D printing. So I will suggest that you new scholar to the antenna theory must explore the possibility of working in the 3D printing antenna, because that is the future I see. So already the 3D antenna is a 3D object only. So that object we used to have individual print, individual design, and we used to fix. But in the 3D printing, everything can be possible in the same platform. So it is the inbuilt type of situation. Like pushing a antenna inside your ear is also possible. Implanting an antenna in your eye is also possible. Implanting an antenna in your teeth is also possible. And these type of things are possible at this stage. So you can explore that. And as you know, this sometimes the dogs which are used for the necrotic search and this type of situations, their teeth is very important. And if a dog teeth agar टूट जाता है, dog ज़्यादा दिन बचता नहीं है. So now one of the projects this institute is doing, the veterinary science department of Ludhiana, they are collaborated with us. जितना police dog है इसी काम में लगे हैं, उनका teeth बना रहे हैं हम लोग. So in this process, something came to my mind. I was discussing with them that they sometimes leave the dog in search of the people. Like in a dense forest, instead of going, they allow the dog to go inside. So now to track that dog, these type of antenna systems, like implanting the antenna on the dog body is possible. Maybe the teeth regions, maybe the ear regions, maybe the tail regions can be utilized for this. And this can be tracked from a remote location where the dog is going and how, so that the action can be taken in that direction. So there are many such interesting fields are coming up now, especially the unmanned space vehicle like drone, for surveillance, for security sake. So the type of antenna requires there are also a different type of requirements. So because these are low orbit flying objects, in the low flying objects, your interaction are to be narrow, pinpointed. It cannot be like covering lot of, but it has to be a multi-band type of situation. So those type of antenna can be designed, and definitely I suggest that 3D printing antennas are the solution for that. In 2016, there is a IEEE Explorer paper. In one of the conference paper, the 3D antenna concept is nicely explained. I forgot the author name. Please go through that paper. If you go to IEEE Explorer in 2016 conference, IRSP or something like that conference, one of the author has given a fantastic paper on 3D printing antenna. So you can have a look to that. And maybe if I come across that article, I'll search that, then I'll forward it to Professor Gautam. Professor Gautam can share with you. So with this word at this stage, actually, to be honest, I'm sitting in the director chair, and my lab, hardly I go. There was a time when I was sleeping in the lab. And during my professor stage also, up to 11, 12 o'clock night, I used to be in lab. So that time, that research which I was carrying with my students had a different type of charm and in-depth understanding. Today, definitely, I am in not that stage. But definitely, with my experience, the way I give my feedback to my students and the colleagues here who are in the group, they are carrying forward good results, good work, mainly for applications-oriented work we are doing. Hopefully, Chandigarh will be in a position to give you a lot of good antennas for many biomedical applications, because we have picked up nice topic here, and they are working on that. So maybe if those results are available to me some days, I'll be sharing with that. These are the results of 2 of my PhD students, which we have shared with you, some sample of that. With this word, I thank you so much. If you have some specific questions with my whatever experience I'm having, I would like to share with you. Thank you so much.
Thank you very much, sir. Yes, from audience side.
Participant.
Good afternoon, sir. This is Manoj Sharma.
Yeah, Manoj, bolo.
Sir,
Yeah.
can you hear me, sir?
Yes, I can hear you. Tell me.
Very good afternoon to Gautam sir, and very good afternoon to Patnaik sir. And fortunately, both are my teachers. Patnaik sir has been my teacher for my master, and I have been fortunate to complete my PhD under Gautam sir. So nice to see, first of all, sir. It's little emotional. And second thing is, sir, just I have a little query actually, because Gautam sir and me, we are working in communication field in MIMO antenna, sir. So we have done some work in MIMO antennas, and then we did try to do power handling capacity improvements in MIMO antennas. So we try to combine these MIMO antennas as well as the what you call this array structure, sir. So now my concern is, sir, that is there possibility, sir, that can we go to improve this power handling capacity of MIMO system, sir? So I am not sure whether right now you are working in communication field, sir. So some idea that we can improve the power handling capacity of MIMO systems.
Actually, one time I was working MIMO when you were a student here. If you remember, MIMO
Yes.
array design was part of my research also.
That's
My
true.
but that time I was confined to a situation of creating a MIMO for the biological application, because I was so attached towards that I didn't want to work in the communications high transmission areas. I was more confined for healthcare system. But we found problem, because when you go for a MIMO arrays for biological applications, So it was not giving that space flexibility to us, and it was limiting us in that respect. So then we thought it is better to work in a single antenna system rather than the array to handle that. But power combining capacity, capability, and enhancement of the power combining capacity, as you know, actually one of the laws which is seen in that is the coupling loss. Because when so that and any joint when you bring that gives a certain amount of discontinuity which we ignore in our analysis, which we ignore in our simulation. So ultimately when you go to the anechoic chamber or the radar rooftop and we start measuring, then we find, oh, I calculated 10, it is giving 5, 3, so that gives a lot of confusion. So now since the printing technology has advanced to a large extent, amplifiers are getting printed along with the antenna, the components are getting printed with the antenna. So it is like the linear combiner, this, that you can plan, design that, and the fabrications can be taken along with your antenna so that it becomes a integral part without having a disjoint, and that coupling parameters you can handle to a large extent, and that will be a substantial improvement. Let me tell you, we ignore that in our design, we ignore that in our fabrication. Even जो दो knot आप जोड़ते हो ना, उस knot का coupling अगर ठीक से नहीं हुआ तो then that also give you a lot of mismatch, because antenna is playing with the match and mismatch. So if you are in a position to improve your match, you are a match winner. If you are if you are not doing that, you are a loser. So that is the fabrication techniques. That is what is the strong fabricators like you were working in that already, Manoj, you are working in that area. So this DRDA people, this that their fabrications, you see their technicians, how nicely they, even small soldering they do. They take so much of care. Even a small tips in our soldering, I told you one Joshi's antenna intentionally that way, that how roughly an antenna can be fabricated. Just to give you an idea that how roughly an antenna can be fabricated, and you can get result out of that also to show to the people. So that even a small tips, extra solder iron, that affects you in a small antenna structure. So that's why I'm telling you this is a good area, because communication, a lot of, especially I suggest Gautam is also a very strong researcher. मुझे लगता है कि ये जो अनमैन्ड स्पेस व्हीकल है एंड ऑटोनोमस व्हीकल जो आ रहा है, जैसे द गूगल ड्राइवर्स व्हिच यू टॉक, हम गूगल ड्राइवर का स्टेज नहीं बोलेंगे, बट अनमैन्ड स्पेस व्हीकल लाइक ड्रोन टेक्नोलॉजी में दिस MIMO antennas are required, because the MIMO antennas are required, and those MIMO antennas, if you can handle well, then starting from agriculture surveillance, animal surveillance, food surveillance, fire, all those things, if you see, आप देखो fire हो गया जंगल में, so that type of fumes which will come, normal MIMO जो आप normal atmosphere में vegetation को search करने के लिए दिया है, वो penetrate नहीं करेगा, because the smoke is too much, so you will not be in a position to really get right kind of data. So in that situations, can you really make it adaptable from the land control systems? You can control that so that power can be increased, which is possible. That is the way it is done. So you think in this direction. Maybe concentrate karo drone, and surveillance drone will be a better approach for us. That you can do it. And Baki Raha, both Gautam is also known to me. You are my ex-student, and you have a direct entry pass to your laboratories. So now lot of infrastructure development has taken place. Later, Chandigarh has gone through a 4. I can give you a simple example. 2017, when I entered, the Scopus H index was 16. Today it is 36. So that gives you the impression कि कहाँ से कहाँ हम पहुँच गए 4 साल में. 16 H index of Scopus, 36 पहुँच चुका है, and PEG is almost all, we are touching the neck of the PEG. Let me tell you, we'll cross that H index in this year. So there is a culture now. You can, and new scholar जो आया, एक mechanical में professor लिया हूँ मैं. This professor has 200 SCI publications. 4 CRC books published किया है. 4 CRC books, 200 SCI publication. His age is only 46. This age में. So that is the type of people I have picked up in this institute. So there is lot of transformation. आप इस facilities में, तो facilities आप लोगों ने create किया हूँ. जो मेरा ड्रीम था, आई वाज जो
Sir,
मेरा
fortunately,
ड्रीम था कि मैं प्रोफेसरों के इधर उधर भाग के सर्च करता था, भाई ये हेल्प कर दो, हेल्प कर दो, मेरा बच्चे को हेल्प कर दो। अभी वो स्टेज में नहीं रखा इस इंस्टीट्यूट में। जे वो यहाँ काम करना चाहता है, उनके लिए जो मैक्सिमम फैसिलिटीज है मैं क्रिएट करके दे दिया हूँ। यू नेम एनी डिपार्टमेंट, दे आर रियली गुड नाउ।
sir,
So in fact,
fortunately,
I also have a very good lab at Pori. So we have another chamber and VNA and fabrication facilities. So nowadays, every institute is creating such
Gautam ji, actually, Gautam ji, what we are making a mistake, that repeatability of the facilities we are creating, rather than doing so, हम जैसे सपोज 20 गीगाहर्ट्ज का फैसिलिटीज अगर मेरा पास मैक्सिमम रेंज तक है, then
Yes.
your measurement facility should be beyond that.
Yes, sir. Yes.
So your student can come here very well as a collaborator. They can stay here. Hostel है, गेस्ट हाउस तो होटल जैसे गेस्ट हाउस में बनाया है वो, जो क्या भी स्कॉलर वॉलर अगर आएंगे तो ये अपना स्टूडेंट आया नहीं, देखा नहीं है। अभी तो यहाँ इसका गेस्ट हाउस में 51 रूम बनाया गया है, जो पहले पीजी हॉस्टल हुआ करता ना, वो हॉस्टल अभी पूरा गेस्ट हाउस कन्वर्ट कर दिया हो। इतना सुंदर ये होटल लाइक एनवायरनमेंट है उसमें। ये इनफैक्ट आप वेबसाइट में जाइए, फोटो देखिए, आपको लगेगा नहीं कि हॉस्टल था किसी जमाने में। So ये अच्छे है, if they want to come in that way, I openly tell to all your participants, this is a government institute. Government has spent money. It is not my money or your money. It is everybody's money. So anybody wants to take this advantage of these facilities, as long as I am chair on the chair as a director, these facilities are open to you. Come for a genuine research, we'll open it up. And हमारा ये जो staff है, they can go to that extent of helping you that even evening time भी खोला जाए। जैसे मैं जब प्रोफेसर था तो रात 11-12 बजे तक महाराष्ट्र ये सब से आते थे बंदे। I used to measure for them. So the same culture is here because some of my students are now, they have joined as faculty here. एक बलविंदर, आई थिंक गौतम को जी को पता होगा, एक बलविंदर सिंह जो धालीवाल था, he is associate professor here in the electronics department. और बलविंदर राज जो एनआईटी जालंधर में था, he is associate professor in electronics department, वीएलएसए में इतना अच्छा काम करता है। इवन जो आप बोल रहे हो ना,
दे रहे हो सर, आप लालच दे रहे हो, लग रहा है निटर में अप्लाई करना पड़ेगा अब।
मुझे बुलाने से मैं एक अच्छा मार्केटिंग एजेंसी है वो, ये आप याद रखना, क्योंकि आई रियली पुल मेनी गुड पीपल टू दिस इंस्टीट्यूट। और मेरा एक ही थ्योरी रहा है कि मेरिट को कंप्रोमाइज नहीं करना है, कोई जान काम नहीं देता है। व्हेन आई सिट ऑन द इंटरव्यू बोर्ड, सो उसी टाइप का वी हैव पिक्ड अप राइट काइंड ऑफ पीपल हियर।
sir, I am requesting Gautam sir to visit Chandigarh many times because I am posted now at Bell Panchkula.
तो ये एक्चुअली एक स्टेप ले लो, बेल पंचकुला को जोड़ो इसका साथ। इतना आरएफ टैंक रिलेटेड काम करते हो, इतना मिलिट्री डिफेंस काम करते हो, कहीं ना कहीं लिसन, one of the facilities which we have created now in Chandigarh, that imagine that the 10 to in electronics department around 8 to 9 QIP PhD students, and in addition to this we have created our own fund for fellowship. So those students can be very well utilized in your research study. They can be engaged in those type of areas. It means that is the way some of your work can be shared with the students and they can do it. जैसे अग्नि मिसाइल का जब काम होता था, इतना एकेडमिक इंस्टीट्यूट, इतना इंस्टीट्यूट को दिया गया था, किसी को पता भी नहीं था कि अग्नि का काम कर रहे हैं बोल के। The ferrite antenna on which I was working, जब इतना साल अग्नि 1 लॉन्च हो गया, जब अग्नि 2 हो गया, तब पता चला कि अरे हम जो एंटेना डिजाइन किए थे अग्नि 1 में रिसीविंग एंटेना यूज हुआ। That's the type of situation.
Sir, some participant want to ask something. So, Mr. Abhay Kumar, do you have any question?
Yes, sir. Yes, sir.
Please,
so it's
please
a privilege. It's a privilege to just listen to you, sir. Sir, actually, I'm working on a SIW technology for a higher frequency range of 28 gigahertz. So what I have given in a paper, and I presented that paper in RFCAT. I have one paper. So I put the SIW horn antenna into a 3-dimensional fashion. So
Okay.
what most of the researcher used to give me the feedback about the reviews, that these antennas cannot be feasible for any type, because mostly people are going towards the planar structure. So as you
Yes.
said that we can go for a printed structure which is 3-dimensional, then how we can give them certain applications in which we can just put our research that these things can also be worked.
Actually, this is a genuine question, and this is what is the antenna engineer they suffer from. That when you want a horn type of output from a planar structure, this is not that easy. It is really challenging. But now, since certain things can be taken care through the material characteristics variations, because ultimately when you are bringing this horn, the mouth of the horn and the fringes which you are creating, all those things are the parameters. They are the contributor to your the signal strength which you are looking forward to. So now if we can go for the printed structure like 3D printing antennas, and we try to go with the minimal volume, that is what the word I use, that volume reduction. Horn is a voluminous structure. So if we can even half volume horn we create and get a output what you are getting in full volume horn which you have designed, that also is a considerable improvement in this situation. So since 3D printing allows you to go for this type of permutation combinations along with the like playing with the material characteristics design in that place. So maybe multiple materials summation will give you a half volume horn which will have the required result what you are looking forward to. If you ask me that purely a planar structure replacing your horn, I doubt, because horn are very high gain antenna. What type of gain we are looking forward to, that cannot be obtained in a small volume planar structure. To get a horn gain, we need to go for RA. This that ultimately the basic objective is defeated, that the space is being occupied. So I'll suggest you that what is the type of gain you are looking forward to, what type of radiation patterns you are looking forward to, look into that and explore. I think 3D will have some solution for that.
Sir, actually, we are working on substrate integrated waveguide. So
Yes.
and this is almost a planar structure. If we are moving towards the horn antenna, if we are making an H-plane horn antenna, we can make with the help of.
Waveguide is a planar structure. That is acceptable. Now, ultimately, are you going for a horn which is a three-dimensional horn, which you are going for the transmission through
No,
a
sir,
horn?
no, sir. We are making an SIW horn antenna. H-plane
SIW
SIW.
horn. Okay. Sort of okay. Surface
So
wave.
that is basically
Okay.
almost planar.
Yes.
So
Then that is feasible. That is feasible in your structure.
yes.
So that is feasible.
So to improve the gain, what we did is we make the structure, like if we are going to put the SIW horn antenna side by side, then it will not going to allow us to maintain the distance of λ/2 between the two horn antennas. So what we did is we put it into a three-dimensional fashion. We put 4 antennas into a three-dimensional fashion. So the overall distance, the center to center distance is reduced, and hence we get a very high gain near about of 18 dB. So this is what we have achieved. But the major issue is that we don't have the facility for the anechoic chamber, and we have the VNA till 30 gigahertz. So we are looking for the facility at our universities. I am from JP University Noida. So I hope in your future I would be taking a help from you, sir, so that
actually my measurement, like I told you, it is 20 gigas. If you are looking forward to beyond 20 gigas, even Thapar Engineering College also they don't have. Their facilities is also up to 20 gigas. And like Professor Gautam told, it is 20 gigas. So more or less educational institute, because of the high cost, they get confined to 20 gigas facilities. You have to take help of some, maybe Samir is a right choice where they have higher frequency applications. So they are anechoic chamber. Maybe some defense organization, DRDO or ISRO, SAC Ahmedabad.
Excuse me, sir. So that is also available in, you can say in JNU, Professor BK Kanodia.
Acha, he is having about 20 gigas. Then
Yes, sir, up to 40 gigahertz he has.
Mr. Kanodia is a very well-known researcher. Then you can approach him. So and JNU you can approach because you are nearby to them, so you can approach. But if you want something on the printing technology, then you can come to my place, because this particular 3D printer, except IIT Kanpur is also having a lower version. We have the latest version that is very costly, 2 crores 30 lakhs rupees 3D printer. So all metals and attached to that also we have a bio printer. So those things are possible. We can extend that.
And sir, one more question. As your research is mainly toward the biomedical application sensors or the antennas, so we are
let me tell you, My research was on the mesial antenna. So then after going to US, I became a antenna person for mobile antenna. And that time I developed this interest of biological based application. So antenna remains, my antenna is metamaterial, metafractal. Then initially I work in microstrip. So those areas were, then that is the way today my application area is biological. Antenna is metafractal, metamaterials, then microstrip. This is the antenna, the plural antenna I work.
So as we are moving toward the IoT applications, I think the biosensors, the medical application sensors, antennas are majorly being used.
Yes.
So thank you, sir, for your valuable feedback, sir. Thank you, sir.
Thank you, Abhay, and best wishes.
Thank you, sir.
Yes, Manisha.
Yes, sir. Sir, can I conclude?
Yes,
Yes,
any.
It is up to you. Anybody, actually, Professor Gautam, if they contact you, and especially taking help from NITR Chandigarh.
Sure,
So
sir.
that you can forward to me. I'll extend that facilities to them.
Okay, sir. Thank you very much, sir. Will do. Yeah, Manisha, please go ahead.
Okay. Thank you, sir. Thank you very much for sharing your depth of understanding and years of research experience with us in the field of antennas in biomedical field, and also making us aware of future research field, which will definitely help all the participants working in this area. Thank you, sir. Thank you very much.
Thank you so much. And thank you to Professor Gautam, especially
It's my pleasure.
running after me to catch me, actually. But I know the dream which you heard from me that Professor Patnaik will deliver. I didn't do that justice, because at this stage you have to realize that I am not in a very aggressive, active research situation. But
experience matter, sir. Experience matter.
But like other administrator, I am not detached myself. Still, I do attend my students and those things, but it is not that aggressive the way I used to do during my professorship career. And it is now a considerable period now, almost all 8-9 years my administration में हो चुका हूँ, BC and this directorship. So therefore, वो जो एक academic inputs रहता था ना, कि एक जो एक भूख रहता था कि सीखना है, करना है, वो कहीं ना कहीं दूसरा एरिया में चला गया अभी, कि अभी फैकल्टी को हेल्प करना है, वो स्टाफ को हेल्प करना है, उस मेंटालिटी में मैं आ गया. So कहीं ना कहीं वो जस्टिस नहीं हो पाया, बट एनी हाउ वंस कम टू मी फॉर वन टू वन डिस्कशन ना, देन वो काफी समय मैं उसको देता हूँ, and we give lot of inputs to our students, so that they can take advantage whenever they want to come and meet me, or even online also is possible. That's not a problem.
Yes.
Okay, then thank you so much, Gautam, and madam, both of you, for a nice introduction and coordinating well. Our best wishes to your team and your institute also. Thank you so much. And do visit whenever the situations is all right for you. Okay.
Definitely, sir. Definitely.
Thank you.
Thank you very much, sir. Okay, then participant will meet tomorrow, and please try to connect earlier tomorrow, because tomorrow we have session from Professor Satish Kumar Sharma.
Yes, sir.
So he is joining from USA. So we have to join earlier, because he was actually requesting for session at around 8 or 8:30. So is it okay with you if you can start at 8:30 or so? Yes, participant.
Yes, we can, sir.
Okay.